For this particular lesson, I'm going to do a lot of talking and not too much writing. What you may want to have are some different colors to help you see on your picture what I am talking about here, because yours aren't in color like mine are. So it might help you to have some different colors for this lesson. Today we're going to look at transformations, how functions move. One type of transformation that you guys did learn in geometry last year are reflections. If I reflect over the x-axis, what I have to end up doing is negate the y values, and that's what this says right there. If you look at the green graph, f of x, for example, the point 0, 1, if I negate the y value, instead of being 0, 1, it's going to be 0, negative 1, and you can see that that's on the blue function. If I pick another point on the green function, let's say 1, 0, I should see it on my blue function as 0, 1. Well, 0, 1 is, 1, 0, 0, 1 would be on my green function, so you can see it there. So it says below, a reflection is a mirror image. Placing the edge of a mirror on an x-axis will form a reflection in the x-axis. This can also be thought of as folding over the x-axis. If the original function is f of x, the reflection in the x-axis is negative f of x. Negate the y values. Reflecting in the y-axis, what you have to end up doing is negating the x's. So for example, we have the point 2, 1. Oops. What I have to do is negate the x value. So instead of being 2, 1, I should see on my red graph negative 2, 1, which I do. Another example, 1, negative 2. Negate the x value, so negative 1, negative 2. And you'll see that each time we do it. The point negative 2, 1 should be the point 2, 1. Okay? So if I want to reflect over the y-axis, you negate your x values. It says placing the edge of a mirror on the y-axis will form a reflection in the y-axis. This can also be thought of as folding over the y-axis. If the original function is y equals f of x, the reflection is f of negative x. Those ones don't come up too often on the Regents, but these next ones do. Shifting it left and right. If I have a function, and I want to, they call it f of x, and I want it to shift the whole thing to the right 2 units to make it the red graph, what you do is you subtract however much, in this case 2, inside parentheses. Now if I want to move it left, I add however much inside parentheses, in this case 2. So moving it left or right, what you have to remember to do is that it is a minus or a plus inside parentheses. Minus moves it right, plus moves it left. And that's what that piece says right there. Now moving it up or down, if I have the green function to begin with again, if I want to move it up to the red function, you add 1 outside of parentheses. And if I want to move it down, say 1, you subtract 1 outside of parentheses. So left and right remembers inside, up and down is outside of parentheses, and up is plus, down is minus. And that's what this piece says right here. And now stretching or compressing does not occur too often, but we do see it sometimes. A horizontal stretch like we have first here. Alright, you started with f of x. If I stretch it out, it becomes the red function. If I squish it up, it becomes the blue function. If I want to squish it, what you end up doing is multiplying by a number greater than 1 inside parentheses. If I want to spread it out, I multiply by a number less than 1 between 0 and 1 inside parentheses. And that's what this piece says here. Okay? Now vertically, it's just outside of parentheses. If I start with f of x, which is my green function, and it's probably easier to see at the bump piece here. If I want to stretch it vertically up and down, make it bigger and smaller, what I would have to do is multiply by a greater number than 1. If I want to compress it, make it smaller, what I would have to do is multiply it by a number between 0 and 1. Multiply it on the outside of parentheses. What I want to do is I'm going to save these problems for tomorrow in class for us to work on a little bit slower. And then afterwards you guys have a worksheet when we get done with that to have you guys practice this stuff.